In this video, you will learn how to build bigger designs using modular design techniques, the use of loops in Verilog, and how to use for generate to make copies of circuits. Given the principal design entity in Verilog is a module, one would infer that Verilog design should be modular. Many tools are provided in Verilog to make this happen, including component instantiation, looping, generate blocks, tasks, and functions. Let's take a look at how to use some of these today. More often than not, at the top level, modular Verilog design consists of component instantiations only, like the code that we see here. Use of component or modular instantiations is the fundamental way to build hierarchy in a design. Consider this example, which creates a 16-bit adder using nothing but instantiations of 4-bit adders. It's true this could be done other ways, and even more efficiently perhaps, but this demonstrates the general technique for building bigger circuits from smaller ones. The intermediate carry wires are needed to stitch the blocks together. There are several looping construct statements within Verilog, including repeat, while, forever, and our old friend the for loop. The for loop statement is written and behaves just like it does in C. This is also true of the while loop, so if you know C, creating these loops is going to be straightforward. The forever loop is explicitly an infinite loop, like a while one loop. The repeat statement executes a statement or a block of statements a fixed number of times. Here's a code example that uses a for loop to AND bits in a vector with a scalar signal 1 bit at a time. This will create n AND gates, showing how the loop can create repeated copies of a circuit very efficiently. Although loops are often used to generate data or test patterns, in Verilog, a common use of loops for synthesis is replication of many identical circuits within generate blocks. The generate end generate block specifies how an object is to be repeated. Variables used to specify the repetition are called gen bars. The index variable for a for loop in a generate block must be a gen bar. Let's look at an example. In this example, we XOR two vectors 1 bit at a time. x1 gets XORed with x2, producing x out. The delay is ignored for synthesis, but helpful for simulation. Note that this does not sequentially XOR the bits, but creates a number of XOR gates in parallel equal to the parameter width. So in this case, the for generate allows you to create many copies of a single circuit all at once. In this video, you have learned how to build bigger designs using modular design techniques, the use of loops in Verilog, and how to use for generate to make copies of circuits.